Hello everyone, this is Karen B, and today I want to talk about the sun. The sun, in my opinion, is the most influential celestial body in our construct. It gives us warmth, it grows our food, it gives us energy and nutrients. The sun is synonymous with reassurance. Every night we go to sleep with the comfort of knowing that there will be a new day when we awaken. As beguiling and nurturing as the sun is to all living things, the sun has been the tool with which we have been deceived. The heliocentric model was conceived with the assumption that the sun is an unfathomable size and an incomprehensible distance from our Earth. Assumptions for which there is no scientific proof, but this is what the entire model is based upon. The good news, however, is that the sun is also the one that will help us to reveal this deception. Because as sure as the sun will rise each day, so too shall the truth be revealed. I'm going to share with you today a series of observations made of the sun by myself and some other dedicated researchers. What you will see cannot be explained by the mainstream heliocentric model. In fact, not only can they not explain it, but they purposefully choose to disregard this information and leave it out completely. Yet it is something so easily observed, anyone with a camera and a solar filter can see it for themselves. This phenomenon is sunspots. Sunspots are defined as temporary phenomena on the sun's photosphere that appear as spots darker than the surrounding areas, considered to be regions of reduced surface temperature caused by concentrations of magnetic flux that inhibit convection. They usually appear in pairs of opposite magnetic polarity. However, today I'm not going to discuss what the sunspots are, but rather how they move on the sun's surface and how we see them from Earth. Mainstream science describes sunspot movement as this. The sun rotates around its axis just like Earth does. Solar features on the sun, like sunspot regions, follow the rotation of the sun. This means that a sunspot region travels across the solar disk from east to west as seen from Earth. This is important because sunspot regions need to be close to the central meridian as seen from Earth in order to be able to send coronal mass ejection towards Earth. It takes a sunspot region near the equator about 2 weeks to move from the east limb to the west limb as seen from Earth. The further away a sunspot region is from the equator, the longer it takes to move across the face of the sun. This is because the sun rotates faster at its equator than at its poles. The rotational period is approximately 25.6 days at the equator and 33.5 days at the poles. Viewed from Earth as it orbits the sun, the apparent rotational period of the sun at its equator is about 28 days. So this video from NASA shows us how they tell us the sunspots move across the face of the sun from east to west. That all sounds good if you live on a spinning ball that is actually orbiting the sun the way that they tell us. But what if you question this? How do you objectively verify their claims? After all, if it's true, then it should be easy to do. The first sunspots were observed around the year 1611 by 3 astronomers through a telescope, Fabricius, Galileo, and Schiner. A quote from Lessons in Astronomy by R.A. Proctor says, "When these spots were first seen, they were watched very carefully, and it was found that they seemed to cross the sun's face from east to west." I won't disagree with that statement. However, there is a secondary motion that they leave out completely and do not even discuss. Here are a series of images taken over the course of one day. You can see the sunspots begin at a certain position and rotate in a clockwise motion when viewed from a location north of the equator. Barely making any progress toward the west side of the sun in one day, but moving quite a bit around the face of the sun. We see here the spots rotate 105 degrees in the time frame of this series of photos, which is 4 hours and 9 minutes in a clockwise motion. Here are two more examples. The first one is taken from Brazil, and you can see the spots move in a counterclockwise motion. The spots have moved 106 degrees over the course of 4 hours and 56 minutes. This next set is from the same day, but taken in the UK. Here you can see the spots have only moved 32 degrees over the course of 6 hours. Are you beginning to see the discrepancy with what we are told and what we see? Well, it gets better. This next set of images were taken by myself during the same day, August 6, 2017. The movement I recorded in my photos was so perplexing to me, I had to check my photos and timestamps multiple times to make sure it was correct. I double, triple, quadruple checked these photos. I can't explain it, but this is what I observed, so this is what I'm presenting. The sunspots seem to make a retrograde motion in this set of images. The spot's final movement is 60 degrees in 6 hours from my location. I knew Anderson wasn't too far off from my time, so I checked his photos against mine. He is 1 hour ahead of me at UTC-3. There is very little movement between his last two photos, and this is the same time I start to see backwards movement in my photos. It looks like he took his last photo right before he would have seen the same backwards motion in the spots. In the week leading up to the solar eclipse, the sun had many spot groups appear. This is my documentation of the sunspots in the days leading up to the eclipse on August 21st, 2017. Watch closely. When the spots get to the center of the sun, you will notice that similar erratic movement occurs as to what we saw on August 6th. I want to take a minute to go over these 4 slides from August 20th, 2017. Between 9 and 10 a.m., the spots move closer to the center of the disk without rotating. Between 10 and 11, the spots make a very slight counterclockwise motion. Then, between 11 and 12, they begin to move clockwise again. This next study is a series of photos taken over the course of 10 days. This set is particularly interesting because you can watch the spots morph and change size as they progress through the cycle. Here, the spiraling motion, which clearly echoes the Fibonacci spiral, can be easily seen as they start on the outside, spiral in, and then spiral back out again. The only excuse I've heard from heliocentric believers is that you need an equatorial mount to compensate for the Earth's rotation. Okay, so let's look at what an equatorial mount is. An equatorial mount is a mount for instruments that compensates for the Earth's rotation by having one rotational axis parallel to the Earth's axis of rotation. One rotational axis. That means that it tracks objects through the sky. So it would have to be turning on two axes in order to compensate for the spiraling motion of the spots throughout the day. But that's not what an equatorial mount is, and that's also not how they say that we're moving through space. So you can't use that excuse. Chris Monk Sellye made this 3D model to help illustrate that this shouldn't be possible to witness on a spinning ball Earth that is orbiting the sun's equator. The camera is fixed on the sun from the observer's location in Brazil. As the ball Earth is spun on its axis, you can see the sunspot doesn't appear to move at all. We shouldn't be seeing this kind of movement. Here is another model where the ecliptic is shown in relation to what the observer should see from the ball Earth's surface as the day progresses. Here we resort to rotating the sun as if we are looking at the sun's pole and the sun is spinning to recreate what we see. Even this does not truly mimic what we see because the spots move inward or outward toward or from the center as well as rotate around the disk.
And again, that comes due to the differential rotation of the sun as the sun rotates faster near the equator versus near higher and lower latitudes.
They start looking like this, and then they start twisting to the point where they started coming out of the surface of the sun. There's all kinds of solar flares and coronal mass injections and prominences, so a lot of activity on the sun. And the whole caboodle, the whole magnetic field lines kind of untwists itself, uncloses itself, goes back to the normal state. The same thing happens to the Earth, except instead of 11 year cycles on the Earth, it probably, the cycles are
more in the order of hundreds of thousands of years.
So whatever result of fusion in the arcs, there's no fusion in the sun. They don't know how the sun works.
Why do you? What's special? How does the sun make light?
It's a transformer. Transforms from some other dimension. It's not burning anything. It doesn't have to. It's a converter.
Of what?
I don't know. Nobody knows. But that's what it does. That's the only thing it can do because that's how everything works.